All right, so we talked about exponential equations yesterday. We're going to talk about its very similar equation in a different way called logarithmic. Logarithmic. So it's logarithmic. Okay, can you guys say that with me? Logarithmic. Okay, say that again. Logarithmic. Okay, that is a really hard word to say, I guess. So we say log. We just call this log. There's also a log button on your calculator, so we're going to use that in the future. Okay, this is how it looks like. Log, and usually it will have a number here, and this part we call that base. And then there's always another number next to it. It is just kind of what it is. And then it may say equal something, it may say not say something. But notice now that your equations is a little bit crazy because you have two levels. There is a base, which is like a subscript level, and then a normal level of writing. So then when you're writing, you have to be very specific of how you write the levels, or else you'll get very confused what is the base. The way you read this is log base b of a equals x. Okay, so the way you read it is log base b of a equals x. All right, so I'm going to show you how exponential and logarithmic functions are related. So yesterday we talked about b to the x, or a times b to the x. Let's say that it's actually equal to a number. So b to the x is equal to a number. I'm going to change this into a logarithmic function, so it looks like a log function. The way you do it is you start with b. We're going to loop around a, come back to x. Okay, what does that mean? I start with b, so then when I write log, I write base b. Okay, I'm going to start with b. I always start with the base. And then I'm going to go around to a. So a is here, or whatever is on the other side of the equal sign. And then I'm going to turn around to the exponent. That is going to be my equal to. Okay, again, I'm going to start with the base. That's going to be the log base. Go around the equal sign. That's going to be the of something. Come back to the exponent, which is the equal to. Okay, let's try one. 3 to the 4 is 81. Is 3 to the 4 81? Yes. Yes. All right, so now we're going to start with the base. We're going to change this to log. We're going to start with the base. What number is the base? 3. Good. So we're going to start with 3. So log base 3. I'm going to go around to 81. And then I'm going to turn back around to 4. So equals 4. Good? Okay, start with the base, go around, come back. Okay, let's do another one. 6 squared is 36. So is 6 squared 36? Yes. Okay. All right, go ahead and do the loop. Guys, good? Okay, Blake, what'd you get for the answer?
Log 6 and 32 please.
What?
Log base 6 of 36 equals
Okay, all right, let's practice saying this. Okay, so you and your partner are gonna practice saying these. So one person is going to do this one person is going to do this one. So just practice saying the answer to your partner. All right, let's try two more. 100 equals 10 squared. Is that in the right, I guess, placement so we can do the loop? No, so we're gonna have to switch the order and then do the loop. Okay, so go ahead and do 2 and 4. Okay, I'm gonna write the answer for you just to make sure you have the right answer. All right, now practice saying the answer to your partner again. So one person take number 2, one person take number 4. All right, are you guys all good? Know how to say it? Okay, now we're gonna go backwards. So we are going to change from logs back into exponent form. We're gonna do the same loop trick. We're always gonna start from the base. So start from the base, go around to x, back to a. So that's going to be b to the x equals a. Start from the base, go around to the equal sign, back to whatever is inside. All right, we're going to do some practice again. Okay. Sorry, did you guys copy it down? Okay, all right. Number 1 on this bottom question, log base 2 of 4 equals 2. Okay, we're gonna start from the base, go around, back. So that's gonna be 2 squared equals 4. Is 2 squared equal to 4? Yes, so this makes sense. We're gonna skip number 2 because I realized the number actually doesn't work. I just made a fake problem. Sorry. All right, let's have you try number 3. Try number 3. Trey, do you have the answer?
I think so.
Okay. What is it?
3 cubed equals x.
Good. 3 cubed equals x. So what is x?
Only 7.
Good. So what we're going to do later on is we are just going to figure out x by solving these. All right, last one. Number 4. Eva, you have the answer? Good. All right, next page. Oh no, my log has no base. Okay, when you see a log with no base like this, it is just base 10. So if you see a log that has no base, it's implied it's base 10 because this is called the common log. So it has right here, common log. Common log means that it is so common that they don't want to keep writing the 10 every single time. They just ignore it. So then when you see no base, you just know it is base 10. So this is base 10. All right, we're going to practice again. We're going to switch between exponential and logarithmic form. Okay, right here, number 1 and 2. All right, let's see. Samantha, what is number 1?
10 to the first equals 10.
Let's see, Sally, what's number 2? We gotta start with a log somewhere. Oh, you said log? Oh, sorry, what did you say? Equals 3. Okay, log 1000 equals 3. You don't need to write log base 10 because log base 10 is implied. It's just common log, so you can just write log. All right, so now what does this all mean? Log is really asking the question, base b raised to what exponent x will yield a. B to the what is a. That's what it's asking. B to the what number is a. Okay, so let's look at number 1. Log base 3 of 81 equals x. Okay, we're going to do the loop rule. So that is 3 to the x is 81. Okay, so when you see a log question, it's really just asking 3 to the what is 81, or b to the what is a. So 3 to the what is 81? 4. So then essentially this whole thing just means 4. It's just saying 4. Okay? Yes. All right, next one. Log base 8 of 32. It doesn't even have an x because it's implied on the other side there's an x. Okay, so what kind of question is this asking? 8 to the something is 32. What's x? Not 1/2. It is hard to solve, right? Okay, well, let's remember last chapter. 8 and... huh? No, okay. Let's try. Okay, 8 and 32, can we change them to have the same base? Huh? Yes, what number? Not 4. 2. Okay, so 8 is 2 to the what power? 3. So this is 2 to the 3x. 32 is 2 to the what power? Nobody knows. 5. Okay. So then 2 to the 3x equals 2 to the 5th. So this is 3x equals 5. So x is equal to 5 over 3. Next one. Log base 3 of negative 27. So it's asking the question. If you need to do loop rule, then you can just do this. Write an x next to it and then do the loop rule. Okay, it's asking the question, 3 to the what is negative 27? What do you guys think? 3? 3 to the third is 27. Negative 3? 3 to the negative 3 is 1 over 27. I? Oh, you can't raise it to an I. Well, let's think about it. 3 to the something means 3 times 3 times 3 times 3, blah, 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 blah. If you keep multiplying a positive number, will you ever get a negative number?
No.
No, it's impossible. So this is no solution. So basically, in short, you can't have negative inside the log. It's just no solution. All right, let's have you guys do 1, 2, 3, 4. Oh, I'm sorry. That's a 1, 2, 4, 4. Okay, number 1 is 4. Number 2 is 3. Number 3 is 3/2. Number 4 is 4. Number 5 is no solution. And number 6 is 1/3. Any questions? All right. Yeah, 6. Okay. So 64 to the what is 4? So 64 to the what is 4? We can change both of them to a base of 4. It might be faster that way. 4 to the 3x is equal to 4 to the first. You got it? Okay. All right. We're going to apply what we know about logs, we're going to use some more log rules. So we're only going to go through the first part of 7.4. Rule number 1 of logs. If you have two logs and they have the same base, if you're going to add them together, you can simplify them to log base b of m times n. If you have two logs, they're added together, you can multiply them if they have the same base. For example, if you have log base 2 of 3 plus log base 2 of 5, it just becomes log base 2 of 3 times 5. If you have two logs with the same base, you're adding them together, you can just multiply those two numbers that's inside. Okay, and then the other one is also true. If you have two logs of the same base, you're subtracting them, then it is the same thing as saying combining into one log, but you're going to divide. First one divide by the second one. So I'm going to use the same numbers again. If you have log base 2 of 3 minus log base 2 of 5, it is the same thing. If you want to combine it into one log, it's log base 2 of 3 divided by 5. All right, let's do some practice. Okay, write the following expression as a single logarithm. So basically, they don't want two logs, they don't want three logs, they just want one log. So you're going to have to combine it together. Number 1, log base 4 of 32 minus log base 4 of 2. Can we combine them together? Yes. Why? Same base. Okay, so what can we do? There's a minus sign, so minus sign says we can divide. Okay, so log base 4 of 32 divided by 2. Okay, you can leave it like that, or you can just simplify it a little bit and leave it as 16. All right, let's try number 3. All right, so this is log base 4 of 15x squared. All right, 2 is pretty much the same example I gave you, so we're not going to do that one. Number 4 requires rule number 3. Rule number 3 says, if you have a coefficient in the front, then what you can do is you can move that coefficient as the exponent of whatever is inside. So this becomes log base b of m to the k. Notice how the levels are very complicated now, so you have to write very carefully. There is a base level, there's a regular level, and there's an exponent level. So please be careful how you write it, so it's very clear. All right. Let us look at number 4. Okay, let's look at number 4. 6 log base 2 of x minus 5 log base 2 of y. First of all, can we combine them together? Yes. Why is that? They have the same base, yeah. Before we combine them together, however, we cannot have a coefficient in the front. We have to move it first. That means the 6 has to go. What can we do with that 6? Move it to
exponent of x.
Exponent of x. So this becomes log base 2 of x to the 6 minus All right, there's a 5 in front of that log. I have to move the 5 first. So what can I do with the 5? You guys look so tired. Or hungry. Maybe it's hungry. Okay, what can we do with the 5?
Move it to the exponent of y.
Move it to the exponent of y. So log base 2 of y to the 5th. All right, now combine them together into one log. So this is log base 2 of x to the 6th over y to the 5th. All right, let us visit these rules, but backwards. Rule number 1. Now, if you see this, we can expand it. So what we did before was we combined all the logs into one log. Now, when we see one log, we can expand it. Okay, so if you see this, we can, so basically if you see a multiply in between, we can expand it so that they're adding to each other. Okay, if you see a multiply, it means split it and add them together. Same thing as rule number 2. Rule number 2, if you see a divide, it is the same thing as expanding it and subtracting. Okay. All right, and then rule number 3 is the same. So if you see an exponent, you can move it in the front. This rule is actually really helpful, the exponent one. All right, so let's practice expanding. Let's go to the next page. Oh, are you guys good? Did you guys copy everything down? Okay. Okay, let's expand this. Log 4x over y. Well, we can read this as log of 4 times x divided by y, right? 4 times x. So if we wanted to expand that, would that be an adding or a subtracting? 4 times x. 4 times x. Is that going to be adding or subtracting? Adding. So that's going to be log of 4 plus log of x. And then we're dividing by y, right? So dividing by y is the same as expanding and add or subtract? Subtract. Are you guys okay? Okay, if you cannot see this, what you could do is see that you basically have 2 things that's divided by each other, right? So you could just think of it like this: log of 4x minus log of y. And then ask yourself, can I expand it more? Well, yes, 4 times x. I can expand that again. So then you can just do this. Okay, so if you cannot see multiple steps at once, this is what you can do. See it as, oh, just one division. Oh, I have more later. All right, let's have you try one. And then we call it a day. Okay, number 3. Okay, and then you can go one more step.